All right, so now we know how to make a polypeptide, right? And a polypeptide will eventually lead to a protein. So this is what is a little bit confusing. Protein, think of them as the functional one, the functional polypeptide. So a protein is what is doing a job, right? It has its function. A polypeptide, what it is kind of the backbone, right? So the polypeptide, you will see in a second that it's gonna have to twist and turn in order to come to the right shape to pretty much fold into a protein. And once it folds into the right structure of a protein, it becomes functional. Okay, so like I said here, shape determines function. So the right shape of a protein leads to its function or job. And how does it fold? Well, the order of the amino acids is going to be extremely important because that's going to affect protein folding. So folding determines protein function. The protein function is only, the proteins only function if they are in the right conformation. So proteins have up to 4 levels of structure, and the levels are going to be primary, secondary, tertiary, and quaternary. And here's an example of them. I'm going to put them in numbers here so you're going to get confused. Okay, this is going to be the primary structure. This is going to be the secondary structure. This is going to be the tertiary structure, and this is going to be the quaternary structure. So let's talk really quick about the primary structure. So the primary structure of a protein, polypeptide, actually the primary structure of a protein is nothing but the sequence of amino acids in a polypeptide chain. In a polypeptide chain. Okay, that's all there is. Just the sequence of amino acids. This is not the 3D shape, not the 3D shape. In other words, this is not really going to work. It still needs to fold. All right. However, the primary structure is extremely important because this one is going to determine, okay, so the right sequence of amino acids is going to determine all other levels of protein structure. Okay, and the amino acid sequence, a little introduction before we move into DNA and nucleic acids. Actually, the amino acid sequence, so the order of amino acids, is actually determined by your DNA, which we'll talk about in another chapter. All right, so again, this is going to be the primary structure over here. You see it, it's just a string of, pretty much a string made of amino acids together. So we got a lot of amino acids, a lot of dehydration reactions, a lot of peptide bonds. That is going to be your polypeptide chain. Okay, string made of amino acids together, and the polypeptide chain is going to be your primary structure. But then what happens? Well, interactions within this chain is going to start it's going to start making it go through some kind of folding. And the first kind of folding we'll talk about is going to be the secondary structure. In the secondary structure, you're going to think about it as in localized. Let me repeat that. It's based on localized folding. In other words, folding in small parts of the huge polypeptide. However, still, the secondary structure is based on the folding of amino acid chains. And the secondary structure is pretty much based on hydrogen bonds. Hydrogen bonds involve hydrogen bonds involving the polypeptide backbone. So remember that the secondary structure is based on hydrogen bonds. And that's what you get to see, for example, here. Okay, all of these are hydrogen bonds. Okay, hydrogen bonds, hydrogen. Well, their folding kind of has two main shapes. Okay, the secondary structure can have two main shapes. One is going to be an alpha helix, okay, which is in a way kind of it's a spiral shape, and the other one is going to be the beta pleated sheet. Okay, I'm going to put here 1 and 2, and this is going to be the alpha helix 1, and this is the beta pleated sheet. And the alpha helix, just remember, it's going to be kind of a spiral kind of form shape, and the beta pleated sheet is going to be like something like this, right? I don't know how accurate this is, but it's like a sheet, right? There you go, by hydrogen bonds. So again, remember, secondary structure is some kind of folding. It's mostly localized in smaller different parts of the polypeptide chain. It's due to hydrogen bonds in the backbone, okay, of the polypeptide chain, and two main forms, alpha helix and beta pleated sheet. And then there's going to be even more folding, and this is going to be the tertiary structure. Let's so we can put it together. Let's just think of the tertiary structure as the complete. Let me actually take this out here and make a little arrow here. Think of it as the complete folding pattern of a polypeptide chain. All right, this is going to be the final 3D shape, final 3D shape of a protein or of the protein. The twists and the folds are the result of the polarity differences in different regions of the polypeptide chain. Okay, uh, the 3D shape is the form that gives the form that gives protein its function. Now, this tertiary structure is mainly due because of interactions between the different R groups. Remember that ones that make the amino acids a little different. So you're going to see different interactions. For example, hydrogen bonds, ionic bonds, disulfide bridges. These are mostly covalent in nature, and hydrophobic interactions as well. Hydrophobic means what? Means fear, right? Fear of water. So some of these R groups are hydrophobic. They're non-polar. If they're non-polar, they're hydrophobic and they don't want to mix with water. So let me show you some of these interactions. Let's say 1, 2, 3, and 4. This is going to be an example of a hydrogen bonds over here, okay, between different amino acids, between different R groups, ionic bonds over here, again, between different R groups, disulfide bridge over here, again, between different R groups, and number 4 here, hydrophobic interactions between different R groups. All right, and whenever you hear these hydrophobic interactions or these hydrophobic ones, for example, these amino acids, I'm going to put an arrow over here. These amino acids are usually going to be in the interior of the protein, okay, kind of away from the water. And the other ones, for example, things that are residues with hydrophilic chains, okay, things that are not afraid of water, they're going to be mostly on the surface of the protein or the polypeptide chain. So this is really a protein. The tertiary structure is going to give you a protein. However, in certain occasions, some proteins are made of more than one polypeptide chain. And this is the case of the quaternary structure. The quaternary structure, think about it as the interaction of different subunits. Interaction of different subunits. Each subunit is a polypeptide chain. Polypeptide chains. Okay, so a quaternary structure is composed of more than one polypeptide chain. An example of a quaternary structure or a protein made of quaternary structure is going to be hemoglobin, which contains 4 polypeptide chains. You can see that here, for example. This is one, this is another one, this is another one over here, this is another one over here. The different colors, okay, represent a different polypeptide chain. But in order for hemoglobin to be able to work, it needs 4 polypeptide chains, okay? And let me just put a little extra note here so you understand this thing about a quaternary structure. It is going to be the arrangements of subunits of peptide chains dash subunits. Remember, quaternary structure contains more than one polypeptide chain, contains several. So it is the arrangement of polypeptide chains or subunits that determine the quaternary structure, and thus the function of the protein.